Okay, next thing we are going to discuss is something interesting. Interference due to three equally spaced sources. We know how to do the calculation if I have two sources. In Young's double slit experiment, we have also done one problem related to Lloyd's mirror experiment, in which single source can be converted into two sources, one single source that is real, another that is a virtual. Now this time we are discussing interference due to three sources. Now these three sources are basically coherent in nature and they are equally spaced. So they are spaced with a distance d here, and another source S3 that is also displaced or spaced with a distance d. These three sources are coherent, that is, they are vibrating in same phase. You can say time period is same. If they have same time period, they call coherent sources. Let us make this diagram first and then we will discuss. Okay, if you have made this diagram, let us proceed. My target is to find out what is the intensity at point P, any general point P I have taken on the screen. This point can vary if I vary the theta. If theta is equals to 0 degree, I will get this point. If theta is 30 degree, I will get somewhere here. If theta is 60 degree, I will get somewhere here. So corresponding, if I change the theta, I will get different point on the screen. Now the next point, if this distance is d, I have to calculate what is the path difference. If this angle is theta, then this angle has to be theta. Theta are basically smaller angles. So I can say d sine theta, this distance is d sine theta, this is basically perpendicular. And then if I apply sine theta, so this is this distance by this distance, so this becomes d sine theta. Similarly, this path difference, now this S1 S3 is 2d, so this becomes 2d sine theta. Let us say three sources, so some important point, three sources are coherent sources. In this case we have three sources, they are coherent sources. Now what is my problem is, I am at point P getting three electric field, one due to source S1, another source due to source S2, another electric field is due to S3. So my point is to find out the equivalent electric field at point P due to these three sources. So my point is very simple. I have to find out the superposition of three electric field. Let us say I assume the first wave, this that reaches at point P, has equation of A cos omega t. So at point this P, this wave has a phase of omega t, and we also call omega t is equals to alpha. So I can write electric field component of wave 1 at P is equals to A naught sine omega t. Now electric field due to 2, this will again become A naught sine omega t. What is the path? So if you see in this case, this is the path and this is the same path. Now this is the extra path. So due to this extra path, I have to calculate what is the phase difference. So path difference is d sine theta. I can always calculate what is the phase difference. So let us apply this rule. If d lambda is the path difference, then phase difference is 2 pi. So if 1 is the path difference, phase difference is 2 pi by lambda. So if d sine theta is the path difference, this becomes d sine theta into 2 pi by lambda. So path difference delta, phase difference delta is equals to 2 pi by lambda into d sine theta. So extra phase due to this path, in this case here you have, due to this path you have extra phase is delta. So let us call this is A naught sine omega t plus delta. That is the total phase at P due to electric field 2. Now similarly, due to 3 I will have a phase of omega t plus 2 delta, because this time we have 2d sine theta. Now we have to add the 3 waves. How can we add? Basically I can use the phasor method to add these 3 waves. Now you see, I can represent the wave 1 where alpha is this A naught. Now this represents the wave 1 with a alpha angle omega t. Now the second wave has a phase of delta more, so I have to rotate this vector by delta. And the third wave also have a phase of delta, so I have to rotate one more time with delta. The 3 waves have amplitude A naught. This will give the resultant wave. Now you see, I can see 2-3 points is important. If I want to find the resultant, I have to take the component of this vector, component of this vector, and component of this vector, and then I have to add. You see, if theta increases, here you see, if theta increases, sin theta will increase. Similarly, delta will increase. So I can say if theta increases, delta increases. But what about intensity? Now you see, if delta increases, the sum resultant will decrease. Initially it's something like this. If this increases, so this will become a smaller and a smaller. At one point of time this will become even 0. So if you increase the delta, this will become a smaller and a smaller. You see, at this point delta is this. If you make something like more, this will come here, this will come here. So delta A will be shorter. So A will be shorter, and intensity is directly related to amplitude. So intensity will be lower. So intensity decrease if you increase the theta. This means as you go away from the center, so this point I can clearly say, if you go away from this point, intensity will decrease because theta is increasing and delta is increasing. So let us write all this and then we'll discuss next. So we make this one. Okay, now you see, let us calculate what will be the intensity at point when delta is 30 degree. So delta is 30 degree, this means delta is pi by 6. So you see from here, what is the sin theta? If I want to know what is the point, so delta is d sin theta by lambda into 2 pi. If I use this formula, delta, so then I can find sin theta is lambda into delta divided by d divided by 2 pi. So I can write sin theta is lambda into delta divided by 2 pi into d. Now I am saying delta is pi by 6. So if I put this value, so sin theta comes out to be lambda by 12d. So this is the point. So this is a point on a screen where sin theta is lambda by 2d. So I am talking a screen where a point I have, this theta is lambda by 12d. So sin theta is, so this point I am talking. So I am interested to find the intensity at this point. What is the intensity? I have taken a general point, but this point is basically theta is equals to delta is equals to 30 degree. जहाँ पे कि वहाँ पे हमारा डेल्टा 30 है, तो साइन थीटा तो हम निकाल ही सकते हैं. सो साइन थीटा इज लैम्डा डी बाई 2 पाई डी. So this is lambda by 12d. So sin theta I know. So I can, if I know the sin theta, I can write pi by d. So I can also know the what is the y value if I know the lambda and d. So if I know lambda and if I know the d, I can find sin theta. If I know the sin theta, I can find what is the position, what is the distance from here on the screen. So what is this distance by? I can always find. Now what will look like the phasor when the delta is 30 degree. So if delta is 30 degree, this let us assume alpha is 0 degree. So phasor will come here. So initially A naught, Now this is A naught with 30 degree angle. Now the next one A naught with again 30 degree, that is the total 60 degree. If I take the x component of the amplitude, so this will come out to A naught plus A naught cos 30. In this case you will have A naught cos 60. So if you add all this, you will have AX component. Similarly, A by component, you will have 0 and A by A naught sin 30 and A naught sin 60. So if you add A naught sin 30, so in this case you will have sin 30, in this case you will have sin 60. If you add, you will have AY. Now the resultant amplitude you can find using x square plus AY square under root. So you will find this amplitude comes out to be 2.73 A naught. Now similarly, so you can copy all this. Now if I want to calculate what is the intensity when delta is 120 degree. If delta is 120 degree, I can make the phasor something like this. Now in this case, the resultant vector is 0. So resultant amplitude is 0. So intensity is 0. So at a point when delta is 120 degree, we are getting a minima. So this is a minima point. Now let us take another point central when delta is 0 degree. So delta is 0 degree, that is sin theta is 0. You see from here I have already said as sin theta and delta are related by this equation. If delta is 0, sin theta is 0. This means theta is equals to 0. This means central point. Now if I make the phasor A naught, A naught and A naught, so basically we will have 3 A naught. So this is a point of maximum intensity, and that's why this is sometimes called primary maximum or principal maximum. Now you see when theta is equals to 0 degree, I am getting 3 A naught amplitude. When 120 degree, I am getting 0 amplitude. When 60 degree delta, corresponding y we can find. When delta is 60 degree, corresponding amplitude is 2.73 A naught. Are you getting or not? Okay, so if I go more, so let us discuss more the same thing I think you have written. Now if you see, I can write the same thing. If delta is equals to 0, y is equals to 0, that is the central point, or theta is equals to 0, A is 3 A naught. If delta is 30 degrees, sin theta is lambda by 12d, I have already calculated. A is 2.73 A naught. And from here we can find y. And we have also calculated when delta is 120 degree, this is theta I can find, and this A is 3 A naught. So A is basically 3 A naught, and theta correspondingly we can find. So this is your task, you can find out the theta. Give me the theta. You use the first equation, delta is equals to lambda d sin theta by lambda into 2 pi is equals to delta. So use this equation at d sin theta into 2 pi by lambda is equals to delta. So I know the delta, I know the d, I don't know lambda, I know the 2 pi, so I can calculate sin theta. So in this case, what will the sin theta here, you can always calculate. Now you see, when I can plot a diagram something like when delta is 0 degree, intensity, amplitude is 3 A naught, so intensity is proportional to amplitude square, so this is something like 9 times I naught. Now when 30 degree intensity is lower, and when theta is equals to 120, intensity is basically 0. So now let us calculate one more. You can also calculate when theta is 180 degree. Now if I calculate theta is 180 degrees, so this is one phase, another wave is something like opposite, so it will come something like this. And now the next one will again something like this. So resultant amplitude will be A naught. Now again you will get something like this. So when theta is 180, you will get another maxima. So this is delta is 180 degree. Now again you will get a maxima, and this intensity is called secondary maximum. Now intensity in this case is only simply single source intensity, because amplitude is related to single source amplitude, so intensity will be simply I naught. That the primary maxima has an intensity of 9 A naught, while in this case secondary maxima has an intensity of only I naught. So there are 9 times decrease. Now you see, let us go. So you keep writing. Now you see, if I keep increasing theta, so I have done up to theta equals to 120, 180. Now this is, we have done up to theta equals to 1, delta is equals to 180. If I go for delta is 360, if I go delta for 360, once again, so in case of delta is equals to 360, you can find using the phasor. So let me draw the phasor here. If delta is 360, you draw the phasor. One is something like this, and another will again something like this, because after the 360 angle, you will come here. So the again something like this, and the third one will be also, if you increase, so third one will be something like this. So you will have again intensity is 3A0, amplitude is 3A0. So intensity will be 9I0. I0 is the intensity of one single source. So once again you will get a principal maxima. So T delta is equals to 360, you will get the principal maxima. So you see, from 0 to 360 we are getting principal maxima at 2 points, at 0 degree as well as 360 degree. So we are getting principal maxima at 0 degree and 360 degree. Meanwhile, we are also getting a secondary maxima when delta is equals to 180 degree. So this means I can generalize in Young's double slit experiment also. We get the maxima when theta is equals to delta is equals to 0 degree, that is lambda is equals to path difference equals to lambda, the second path difference is 0, 2 lambda, n multiple of lambda. Now the same thing we are getting here also. So now I can generalize d sin theta is equals to n lambda. How many source we have, this does not matter. I will have a 2 source, I will have 3 source, I will have 4 source. Principal maxima will occur only if d sin theta is equals to n lambda. This result even holds true for 4 equidistant sources. So if you have 4 sources, S1, S2, S3, S4, so path difference this, and path difference this, and path difference this, you can always find d sin theta, 2d sin theta, and 3d sin theta. If I do the same thing, I can write electric field A naught cos omega cos alpha delta plus 2 delta plus 3 delta. Now if you take delta equals to 0 degree, you will find intensity is 4A naught. So if you take delta is equals to 0 degree, this means this corresponds to theta is equals to 0 degree. Once again intensity is 4A naught. You see, even if you take delta is equals to 360 degree, again you will find alpha, you can find it out, and theta. So what is alpha? Let me see. This one is alpha. So when theta is equals to, for a special case I have taken alpha is equals to 0 to solve the situation easily. Now when delta is equals to 360, once again you will amplitude will be 4A naught. So amplitude will be 4A naught in this case also. So you see, even if you have 4 sources, you are getting maxima at 0 or 360 when delta is 360. This means lambda, 2 lambda, 3 lambda. What will the point of minima? You can find when theta is equals to 90 degree, these 3 waves add up and come out to be 0. So in this case, this means at theta is equals to 90 degree, delta is equals to 90 degree, you will get a minima. This graph we have plotted for alpha equals to 0 degree. So this means maxima will again occur at lambda or 2 lambda or 3 lambda. Minima in this case will occur at 90 degree. You see what we are doing, 360 by n. If you have 3 source, minima occurs at 120. If you have a 4 source, minima occurs at 90 degree. If you have 5 source, so 360 by n, this is a point where you will have minima. So delta, if satisfy 360 by n, where n is the number of sources, you will get the position of minima. This is important. A maxima you will get only if delta is equals to 2 pi, 3 pi, lambda. This means delta is equals to 0, 2 pi, 3 pi, or path difference is lambda, 2 pi, 2 lambda, 3 lambda. Are you getting or not? Now if you see, if you have two source, intensity will be 4A naught, because resultant amplitude will be 2A naught, intensity will be 4I naught. If you have a 3 source, resultant amplitude will be 3 A naught, intensity will be 9 I naught. If you have a 4 source, resultant amplitude will be 4 A naught and intensity will be 16 I naught. So if I plot this graph, if you have 4 source, intensity will, again you will get the intensity when theta equals to 0 degree or delta is equals to 0. In this case, intensity will be more. If you have 3 source, intensity will be even less. If you have 2 source, intensity will be even more less. So this point, this is the important point. Whatever we have said, this problem is important problem. Now you see 2-3 points is important. We said first point, if you have 3 sources, more than 3 sources, you can add only using the phasor method. You have to use the phasor method. And in these cases, sources are basically equidistant. So delta, 2 delta, 3 delta are the extra phases. That is important. Next important point we said, to find out the maxima, principal maxima. There are two kind of maxima, principal as well as secondary. Principal maxima is the maxima where you have intensity maximum, but secondary maxima is the maxima where intensity is between the global maximum and local minimum, global minimum, but not global maximum. It's not equal to global maximum. Now in this case, in 3 sources we have calculated this maxima come out to be 180 degree, delta is 180 degree. Similarly we can find for other sources also. Now you see, the third point, important point, is principal maximum will always occur when d sin theta is equals to n lambda. It does not matter whether the source is 2 sources, 3 sources or 4 sources you have. In case of minima, how to find out the minima? Minima will generally or always occur when delta is equals to 360 by n. When 3 sources, 2 sources, you will have a minima at 180 degree, delta is 180 degree. If you have 3 sources, delta is 120 degree. Similarly you can find. And the third point I said, if you have more than 2 sources, intensity will gradually increase at central maxima. Like if you have 4 sources, intensity will be 16 I naught. If you have 3 sources, intensity will be 9 I naught. If you have 2 sources, we always know intensity will be 4 I naught. Now whatever the calculation we have done, now we can extend to the diffraction. We can divide any given slit into n number of small slits, small sources, and then we can do the interference of these sources, and this will lead to the calculation of diffraction. So we'll discuss in the next class how to find the diffraction pattern, how to find the intensity of diffracted rays using the idea of phasor, using the same idea. Only thing in this case, sources S1, S2, S3, we have 4 sources. Now we can have n sources, S1, S2, S3, S4, S5 up to n, and then we can find intensity of resultant all these sources, and that is the basically calculation of diffraction. So you can see diffraction is nothing but n number of single sources interference. If you have 2 sources interference, we call it YDS, Young's double slit experiment. If you have n number of sources, they interfere, we call it diffraction. So diffraction is no different kind of observation. It's a basically summation of interference. If more than 2 sources interfere, we call simply it as a diffraction. So this is the end for this class. We'll discuss some more problem in the next class.